Beer's Law Lab. We're going to study Beer's Law by doing a lab using copper 2 sulfate, and to begin with, we're going to have to get our stock solution made. Now, because I'll be using this for multiple classes, I'll need 124.85 grams of copper 2 sulfate pentahydrate because I'm going to make 0.5 molar concentration, and I'm going to make a full liter of it in a 1,000 milliliter volumetric flask. Now, this could take some time, so go ahead and skip forward. And what's going to happen, though, is I'm going to reach my mass, exceed it by a little bit, most likely, and then I'll have to remove some using a microspoon or a scupula. Now, whatever I remove and take out to match my correct mass, it cannot go back into my reagent container. So I've got a smaller weighing tray where I'm going to put the excess into it. That way I can use the proper disposal and get rid of it. Once we have the appropriate amount of solute, we're going to go ahead and put it into our volumetric flask. Before we do that, we should put a reasonable amount of distilled water into the volumetric flask so that as soon as the solute reaches the solvent, it can start dissolving. I'll get a funnel and I'll start adding the solute. This is definitely going to take some time, so if you'd like to fast forward, you can. Here's what's going to happen overall. We're going to go ahead and make this into a little bit of a taco and sort of shake it into a funnel. I'll tap the funnel at the top of the volumetric flask and have it slowly but surely go through the funnel hole and into the volumetric flask. When I'm done with that, I'm going to fold my weighing tray into a taco triangular shape and take a wash bottle and spray it into the funnel. That way I can get all residual solute particles that are in my weighing tray into the funnel and then into the volumetric flask. I'll then wash out the funnel thoroughly and make sure everything's washed down the neck. I can then go ahead and add additional water using the water carboy off to the side, but I'm going to stop right at the bottom of the neck. What's going to happen is I'm going to become very, very familiar with, ooh, it's rising, it's rising, it's rising. It's taken a while. As soon as it hits the neck, it's going to speed up and start filling much, much faster than I anticipate, and sometimes the line that they put on the volumetric flask is rather low on the neck. So I find it best to stop at the base of the neck and then use a wash bottle to fill it up the rest of the way. I won't fill it all the way up to the line. Instead, I'll go ahead and cap it, swirl it around, invert it, and go ahead and do that several times so that the solute can fall through new solvent that is unsaturated. This will help pull the solute in. If I were to just shake it up and down or try to swirl it, what you'll find is the solute particles take a while to dissolve because they're really not seeing any new unsaturated solvent. After this, we can go ahead and wait until it comes to room temperature and then fill it up so that the line, the meniscus line, sits right on top of the volumetric flask line. This will allow me to have a very accurate amount of volume. 1,000 milliliters is what we're going for. You won't see me do that. I immediately went ahead and started making my solutions and started testing them in 2 separate spectrophotometers. Both spectrophotometers are set to 635 nanometers for the wavelength because of the color of the solution, the identity of the solute, and other tests that others have done ahead of time to tell you what would be best for that spectrophotometer. If you're taking an AP or a college class, you might be tasked with trying to figure out the exact wavelength that you should use. With the analog machine, I am given more control and freedom to set my limits on the gauge. I'll first put in a blank, set it to 100%, then put in my highest concentration, which will be a 0.5 molar concentration, and try to set a minimum. I'll then put the blank back in, make sure that any adjustments that I made allow the maximum to stay at 100%. If it does change, I'll have to toggle it and go ahead and put the 0.5 molar in, make sure it's still on my gauge. But once that happens, I can go ahead and start testing all of my solutions. With the digital version, I'm at the mercy of the machine itself. I'll put my blank in, I'll press a button to blank it and set it at 100% transmittance, and then I'll put in all of my samples. I do put the blank in at the very end to see if the calibration has stayed. You'll notice that it changes slightly on the digital, but not on the analog. When you're done, make sure you complete your lab report. Realize that when I did this, I made 0.5, 0.4, 0.3, 0.2, 0.1, 0.08, 0.06, 0.04, 0.02, and 0.01 molarity concentrations. I only tested down to 0.02. The 0.01 was left off. This in part was due to me wanting you to use the provided data on the lab report rather than using any of the data that you see here. Again, fast forward and rewind as necessary to see where everything is, and go ahead and read the text that's been placed on top of the video. Thanks for watching.